Solve graphically. So we're gonna graph the left-hand side and the right-hand side of this equation. So you're gonna set each side to y, so when you're graphing it, you've got an equation to work with. So we're gonna graph y equals the absolute value of 2x minus 5, and then you're gonna graph the right-hand side, 5 minus 3x. So let's start with 2x minus 5. Again, I need a pencil with my absolute value. And so negative 5 is down here. My slope is 2, so I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, etc. And we're going to connect that. And everything above is going to flip up. So instead of being at negative 1, this is at positive 1. Negative 3, it's at positive 3. The other thing I like to do sometimes is I really just know my slope's now negative, so I can keep counting 2, 1, up to left 1, up to left 1, and I don't have to necessarily line up my points. So this is now my graph right there. I have an intercept at 2.5, which makes sense. I'm going to label this as y is equal to the absolute value of 2x minus 5. And away we go. Let's get the second graph drawn. So y equals 5 minus 3x. I prefer to write the equation in y equals mx plus b form so I can see that. So now I have my y-intercept of 5. My slope is 3. So I'm going to go down 3, 1, 2, 3, right 1. Down 3, right 1. Down 3, right 1. Down 3, right 1. If I want to continue at the opposite, I'd go up 3, left 1. So there is my linear graph. Now this one does not have an absolute value bracket around it. So you do not reflect this one. This one had the absolute value. It's the V shape. This is still a linear graph. So we're going to label that as y equals 5 minus 3x. So it crosses only in one place at x equals 5. So at x equals 0 on the y-intercept of 5. So the solution would be x equals 0. Remember, it's always the x value of intersection. That's important because anytime you solve graphically, that's going to be true. So that's a concept we'd want you to know. Now, I just want to point out that this technically was the same example as we had done previously algebraically. And so when we did this one, I'm just going to grab the same example. We had done this one algebraically already, and we got x equals 0 as an answer. We also had an extraneous root of x equals 2, but you won't see the extraneous roots when you solve it graphically, which is why we don't have to then verify. So maybe let's just make a note. Solving graphically does not show extraneous roots. So you wouldn't be expected to find them or state them if you solve it graphically, but you are expected to find them and state them if you solve it algebraically.